All right, welcome to this explainer. Look, if you're an IT student, a developer, or just someone obsessed with how the modern web actually works, you are in the right place. Today, we're diving into the absolute builder's blueprint for taking your code out of that cozy local environment and launching it straight into the global cloud. We're going to see how a tool called Terraform completely bridges that gap, making it super seamless to deploy Python, Flask apps, and Docker containers. I'm seriously excited to jump in and show you how to take a project from living on your laptop to functioning out there on the internet. Let's do this. So here's our roadmap for today. We'll start with a quick introduction to Terraform, then move on to deploying Python Flask, followed by deploying Docker containers. After that, we'll look at some real-world cloud deployments, and finally, wrap up with best practices and challenges.
Okay, let's dive into this with Section 1, Introduction to Terraform and Building the Foundation. To really wrap our heads around Terraform, we first got to talk about Infrastructure as Code, or IAC. You know, back in the day, setting up a server meant literally manually clicking through a web console for hours. And then, at the end of the day, you'd realize you missed one tiny firewall rule and bam, nothing works. It was tedious, it was frustrating, and yet incredibly prone to human error. But Infrastructure as Code, it completely changes the game. It lets you manage and provision all your stuff, your virtual machines, your networks, your databases, just by writing code. Terraform basically acts as this fully automated, codified blueprint. You write down exactly what you need, and the tool just builds it. No more endless manual clicking.
And you know what makes Terraform so incredibly powerful, and honestly the industry standard right now? It's the versatility. You aren't locked into just one single provider. Actually, it acts more like a universal language. So whether your project runs on AWS, Microsoft Azure, or Google Cloud, you're using the exact same principles and workflows to spin up your infrastructure. You literally learn this unified approach once, and boom, you can deploy practically anywhere.
Moving right along to Section 2, Deploying Python Flask, your first blueprint.
So, picture this. You've just built this amazing Python Flask app locally on your laptop, and you are ready for the world to see it. Getting it up to the cloud is actually a surprisingly straightforward three-step process. Step 1. You create a Terraform configuration file. Think of this as your blank canvas. Then, Step 2 is where the magic really happens. You define your infrastructure resources right inside that file. You're literally writing code that says, hey, I need a virtual machine, I need this specific network setup, and oh, I need a database. You are drafting a tangible, reviewable blueprint of the entire system. And finally, Step 3, you just run a simple terminal command, Terraform apply. That tells Terraform to read your blueprint, go talk to the cloud provider, and actually build out the resources exactly how you define them. Pretty cool, right?
Next up is Section 3, Deploying Docker Containers, Boxing It Up.
And this brilliantly illustrates where the elegance of Terraform really shines. When we pivot to containerization, it is the exact same workflow we just used for Python Flask. Step 1, create that configuration file. Step 2, define the Docker container right alongside your necessary infrastructure resources. And Step 3, run that faithful Terraform apply command to provision the whole shebang. Shifting your deployment strategy from a standalone Flask app to a containerized Docker environment doesn't mean you have to go learn some entirely new language or crazy workflow. Your blueprint just easily adapts to fit the new architecture.
All right, let's get into Section 4, Real-World Cloud Deployment, taking this from theory to practice.
Things get really interesting when we compare two realistic scenarios side by side. So on one hand, let's say you're deploying a Python Flask app on AWS. That means defining very specific native resources in your code, like an EC2 instance to host the app, an RDS database for your data, and an S3 bucket to handle static files. Terraform beautifully coordinates all those native AWS services together. But then, on the other hand, what if you're deploying a Docker container environment on Azure? That requires entirely different native services and a totally different architecture. But here's the amazing thing. The engineering approach remains exactly the same. You just write the configuration for the resources you need, and you let Terraform handle all the heavy lifting of provisioning. It's that simple. Which brings us to our final stop, Section 5, Best Practices and Challenges. Consider these your pro tips for the real world.
Look, when you're managing actual real-world infrastructure, there are a few best practices that are absolute lifesavers. First up, always use version control. I mean, since your infrastructure is literally code now, you gotta store it in Git to track every single change. That way you can easily roll back if things go south.
Second, make sure you test and monitor everything so you actually know your setup works before it goes live to users. But honestly, the real game changer here is using Terraform modules. It all comes back to that classic coding principle, DRY, or don't repeat yourself. Modules let you package up and reuse your infrastructure code, which keeps everything incredibly clean, super efficient, and totally free of annoying duplication.
But, even with all those best practices firmly in place, we all eventually have to face the ultimate boss battle of Terraform. So what happens when manual changes completely ruin your state file? Trust me, it is a shared IT nightmare. See, Terraform relies on this state file to remember exactly what it built. But if a well-meaning coworker decides to just log directly into the cloud console to, say, urgently tweak a security setting without updating the code, panic sets in. Suddenly, your pristine code and reality are completely out of sync, and Terraform's memory is totally broken.
Fortunately, there are specific hero fixes for these exact gotchas. When you're staring down an outdated state file because of those pesky manual tweaks, your solution is the Terraform refresh command. It essentially forces Terraform to look at the real world and update its memory. It's kind of like hitting a much-needed reality check button. Now, another major hurdle is handling dependencies, like making absolutely sure your database is fully spun up before a virtual machine tries to talk to it. The fix here is using Terraform's built-in dependency management, specifically the depends on argument. This explicitly dictates the exact order resources have to be built, guaranteeing that everything connects perfectly on the first try.
So, we've covered the jump from local code to the cloud, the sheer power of infrastructure as code, and the real-world strategies for getting Flask and Docker deployed smoothly. Which really brings us to one final big question. Is manual infrastructure completely a thing of the past? After seeing how Terraform automates blueprints, handles massive cloud architectures, and practically wipes out human error with just a few lines of code, the answer seems pretty clear. It might just be time to abandon those manual console clicks for good. Thanks for exploring this with me on today's Explainer. Keep building, keep learning, and I'll catch you next time.